like your parabola, your square root, your absolute value. So that's where the f of x comes from. Then we're going to apply transformations. This is a very important slide for you to write down. I also have it on my whiteboard for Algebra 2, so I'm going to leave it up there for you also. So the first transformation is when we physically move the graph up or down so many units. That's the orange one. So if it is a plus k, let's say it's a plus 3, we would move it up 3 units. If it's a minus 2, then we would move that graph down 2 units. And sometimes they try to trick you a little bit. They put that plus k or minus k sometimes in front of the function. I always tend to rewrite it and throw it on the back. We try not to trick you when we write tests and quizzes. We'll throw them on the back side for you. Give you some time to write down that orange transformation. Yep, we get to write all of theirs. This is a long slide. It's all the transformations that you see over on the whiteboard right now. They're on this smartboard slide. The second transformation is a horizontal shift. We call these translations. They're moving the graph right or left. And I tend to think of them as inside the function, and we physically move it left or right, and I think opposite. So if it's a plus 5, you move it to the left 5 units. If it's a minus 5, then we move it to the right 5 units. Okay, we'll come back to this slide. I just want to show the difference between when you see a function with the transformation at the end and when it's inside, what the difference with the equation would look like. So let's say our original parent function looks like this. The absolute value of x. Do you know what the shape of that graph looks like? Of that parent function? What would we say that? A V, right? So our critical point is 0, 0. And then we remember graphing these earlier in our chapter. This is 1, 1, negative 1, 1. And it goes off like that. That's our parent function for an absolute value. Now remember, we can apply all those transformations. We're just going to focus on those top 2 transformations. So let's pretend I have a new function, call it g of x. And I say the absolute value of x, and then minus 4. That's at the end of the function. So where am I going to move that graph? Down 4. So now I focus on that critical point, the 0, 0. And then my shape has not changed. So, and there is my blue function where I move it down 4 units, vertically translated down 4 units. Now let's make up one more function. Let's say I call this h of x. And now notice the difference where that transformation is. It's going to be inside that absolute value. So now where am I going to move this v? to the left. And I always say think opposite. So I'm going to move to the left 3 units. So I pick up that black parent function, and I move it to the left 3 units. Some students last hour said they remember doing this in Algebra 2, and for those of you who had FST, you did it again in FST. So hopefully now, this being the 3rd time, some of those transformations start to click and you're getting a little bit better at them. Just remembering them all and how do they apply from the parent function to our new function, because we want you to move away from doing an XY chart where you use a point plot, where you say, let's substitute 0 in, let's substitute 1 in, let's substitute 2 in, and then you graph it out. We're moving away from that now. Okay. We're going to move back to this slide. So we've covered the vertical and horizontal. The next one is our reflections. Reflections across the x-axis and reflections about the y-axis. When you have an x-axis reflection, there is going to be a negative in front of the function. The difference with y-axis is it's going to have a negative inside the function. And think about when you do a reflection, you fold the piece of paper, like an imaginary dotted line along that axis. Now let's just make up a problem. And we'll come back to it. So now let's focus on the parent function for a square root. It starts at 0, 0, and then 1, 1, and it kind of goes across like that. Half a parabola. Now let's do a reflection about both axes. G of x equals the negative square root of x. So of the two axes, which end am I going to reflect by? The x-axis or the y-axis? Where is the negative at? Is it inside or in front?
The x-axis.
The x-axis is in front. So we're going to reflect about the x. So I go over to the x-axis and imagine folding the piece of paper along this dotted line. So what will my graph now look like? Yes, sir?
It's been about 10 minutes.
Thank you. We'll finish this problem and I'll cut it off. So it looks like that. Now just make up the problem and see the difference. H of x. Now notice where the negative, it is now inside the function. It's underneath that radical, that square root. So now we're going to reflect it about the y-axis. So now we go along the y-axis. Imagine folding along that red line. And now what will the graph look like? We fold it and go this way. There is reflections for you. We're going to stop the recording here and pick back up.